Welcome to M2. In this video we're going to look at frameworks in equilibrium. Now these can be solved in very much the same way as in the previous video, which was our laminars in equilibrium. So without further ado, let's just jump straight in with an example. So in this example we've got a lot of information here. A lot of it's just setting up the question. See, we've got two vertical strings attached to A and D, and it's holding this horizontal, and of course they all lie on the same plane. Very straightforward stuff. So work out in terms of W the tensions T1 and T2. So for us to first do this, we do need to know the center of mass of our framework. So let's work that out first. So let's set F as our origin in this one. Okay, so everything's kind of going from that point F here. So that's like my origin. Done that as the bottom left one, because then everything's just positive values, X direction, Y direction. Okay, I know in some questions you could also go on and say that, FE lies on X axis, FA lies on Y axis. So you can go a step further, but this should be more than enough. So if you remember, finding the center of mass is all about the midpoint of each of these lines. And just while I'm doing it, let's also put this value in here. We got 8 here, 3 across, so this is going to be 5. So let's pop that one in. So I'm just going to go around from F. I'm going to go around horizontally. That's not really a direction, is it? I'm going to go around in an anti-clockwise direction here. So I'm going to do this one, this one, this one, this one, this one, and then this one. So first we've got 8, and then halfway across is going to be 4 across, 0 up. Then we've got a length of 4, and that's going to be 8 across, 2 up. Then we have a length of 5. Now the 5, this is 3, and then halfway along there is 2.5. So 3 and 2.5 is going to be 5.5. And of course it's 4 up. Now we're looking at our BC. So that's 4, and then halfway along the 8 is another 4. So we've got 8 up, and we've got 3 across. So that is 3 across, 8 up. Now we're on the top AB here. So you can see now it's 1.5 across, 12 up. And then finally we have our 12, which is 0 in the horizontal and 6 up. And then I need to total this up. Quick way of doing it is 12, and then this has got to be 12, isn't it? Yeah? You got 8, and this is 8. So 12 and 8 is 20, doubled is 40. So nice and quick way there to get your answer. So 3 across, 5 up. You're gonna see it somewhere like here on this line. 3 across, 5 up there. Now just make a little bit more room for us to continue with the question. Now remember, our framework is in equilibrium. That makes our lives a lot easier here. So first let's resolve vertically. So that means we got T1 plus T2 is going to be equal to my W. Of course, that W is acting here. Once I've done that, then I want to take moments. So taking moments about. Now you want to take this about either A or D so you can get rid of one of your tensions. So let's take it about A. So that means that if I look at where my W is, that is a distance of 3 there, perpendicular distance. So we've got 3W going in one direction, which is this direction. And now T2 is going in this direction, and that's a distance of 8. So that gives me 8T2. So we've got T2 is 3/8 W. Okay, and then using, this equation, I just label it 1 there. So from 1, we can say that T1 equals, jumping too far ahead there. T1 plus 3/8 W equals W. So T1 must equal 5/8 W. And there we have our two tensions in terms of W. Now we can move on to question or part B. Just as a reminder here, so the string at A snaps, so this now snaps, and the framework is hanging in equilibrium, suspended just from D. Find the angle that DE makes with the vertical. So what I'm going to do here is I'm just going to redraw this just so that you can see. Obviously in an exam, you wouldn't probably bother too much, or maybe do a quick little sketch. It's up to you. And remember, we join essentially through our centre of mass and that point where it's being hung by, and these need to hang vertically. So just turn them around here. Now you can get an idea of what the diagram will look like. And finally then the angle the vertical makes with DE is there. So let's pop that on, let's make it nice and clear for you to see. It's this angle here, let's call it theta. Okay, so there we have it. In fact, let's, just to help you guys see it a little bit better, let's get rid of a little bit more there. There's my angle there, theta. Now I'm going to need the size of some sides. If I carry on following this down, same diagonal here, that's parallel with this one, so this theta and this is theta. So here we also have theta. So that's the triangle we're actually going to concentrate on. That's the triangle that goes from G to D. Theta is there. And we can work out our values, and that one is C, isn't it? So from G to C has got to be 1, isn't it? Because this distance was 4, which I have rubbed out now, but this distance was 4, and the distance here was 5, wasn't it? Because that's the Y value. And then this distance here is 3, but this total distance is 8, so this is 5. We did have that written on a previous one. So that's 5. So we get tan theta is 5/1. And that gives me 78.9 degrees to 3 significant figures. Okay, hopefully that wasn't too bad to follow. And like I said, a lot of these questions are similar to the last one, which is why we're kind of looking at ones where the rope or the string is snapping. So I'm just going to pop up a couple of questions for you to have a go at, and I'll pop the answers at the end as always. So this one we got it freely suspended from point D and hangs in equilibrium. Find the angle between CD and the downward vertical. So first thing I need to do here is find the centre of mass. So again, we're going to start at A, so taking A as origin, and of course AB will be the y-axis, and AF the x-axis, or lies on those. I'm just popping them in very quickly. So let's go round in kind of order, so let's go 5 times, and this is going to be 2.50, I need to work out this side here. So this is 5, total 15, so this has got to be 10. So we got plus 10, and we're going 5 across, and half of 10 is 5. And then we got this side to work out, so that's 10, and this is 5. So let's pop these 10 in, and then this one's 5. So we got 5 lots of, and we go across 5, and then another 2.5, so 7.5 across, and we're going up 10. Then we got the 5 for CD, that's where we are now, so that's 10 across, and in total we've gone up 10 plus another 2.5, so 12.5. Top one is 10. Now we're going halfway across, which is 5, and we're 15 up. And then final one is 15, and that's 0 across, 7.5 up. And then let's work at the totals. So we've got 15 and 10 is 25, so this is going to be 50. Remember, just to make it a little bit quicker, working these out. As you know, this distance and this is equal. This distance along with this and this are equal. Now we have our centre of mass, so 4 across, 8.5 up, so somewhere in there. That's all we're thinking about. And we know it's going to join at point D. So that's what we kind of got to join our straight line with, between G and that point D, which is where it's hanging from, isn't it? That is essentially what we're looking at here. So let's actually make a little bit more room and resketch it. And here we have it hanging. So we can look at the angle that the vertical is making with CD there, as that's what we had to find. And again, very much like a previous question, that would be the same as that angle there. But that still doesn't help us, but if I extend this down and look at this triangle, it'll be the same as that angle there. So let's re-sketch that triangle, because that's what it's all about. So we've got G here and we've got D here. And I do think redrawing these triangles really help. So this distance here is the same as E to G, isn't it? So this is equivalent to EG, which actually is probably a little bit easier to see on my original diagram, but this distance here is 10, this distance up to G was 8.5, wasn't it? So this distance is going to be 1.5 there. And then I'm looking at this distance in total. So easiest thing is to G is this was originally a horizontal distance, which was 4. The total distance is 10. So if this is 4, this is going to be 6. And then we've got our tan theta. Our theta was here. So opposite over adjacent. And that gives me 76.0 degrees to 3 significant figures there. Just being careful with this triangle. Obviously I've re-sketched this, but you can't quite see the rest of my diagram up here. But obviously if you're doing it in an exam, you'd have this and any sketch you might have. So it's a bit easier to see on the original. Now, we've got the same framework here. Mass M, it's got a particle of 0.15 attached to F. So we've got 0.15 kilograms there, and it's going to be suspended about point B, and it's going to hang in equilibrium. So the first thing we want to do is find our new center of mass. So our overall shape is m kilograms, and the original centre of mass is 4 across 8.5 up. The 0.15 m, that's attached to F, so that's 5 across 0 up, and that's going to equal 1.15 m, and x bar, y bar is the new values we want to find. We can cancel through by our m's, and that leaves me with 4 and 8.5 plus 0.750 and equals 1.15 our x bar, y bar. So our new centre of mass is at 95/23 and 170/23. So just in terms of our diagrams, the drawing, this is approximately 7.4 and our x value is approximately 4.1. I mean, I could actually use approximate signs here just to show you. So now what I want to do is work this out. So it's attached to B. I'm going to need a new diagram with a new value of G. And we're going roughly 4.1 across and 7.4 up. And we're suspended from B. So let's draw a nice big straight line through that B. Now it asks me for the angle it makes with BC, so let's mark that angle on there, and obviously this is our G, and G is at 95/23 and 170/23. So all we need to do here is find our angle. We can do that by kind of making pretty much, there's a few options here. So if I go straight up there, as I know these distances, so I can redraw this triangle like so. There is my theta, and that is point B, point G, and I know that this distance here is this horizontal distance, which is 95/23. And when I look at this distance here, well, it's this total distance 15 minus this height here. So this will be 15 minus 170/23. So we get tan theta is opposite 15 minus my 170/23 over 95/23. And to my calculator, that will give me 61.5 degrees to 3 significant figures. Now, final question. Hopefully not too difficult, but this time we don't have two vertical tensions here, two strings. So that will have a small impact as we go through it. Now let's start off by putting in my values. So AB is 6, AH is 4, BC is 2, CD is 3, and DE is 10. I'll just pop in the other values there. Also we know 2, 4, 6, so this has got to be 4 there, and obviously that one's 6 there. So we need to work out, in terms of W, the tensions T1 and T2. So what we want to do here is start by finding the centre of mass of this framework. So let's make A the origin here. Make our life, well, there's no super easy way on this one, is there? And what I'm doing is I'm just going to go around in this direction here. So I'm going to go here, 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 here. Now, this is obviously 1, so actually I won't do that one, I'll do that one in one go. So we'll do AB first, then let's start there. So that AB is 6, and the centre is going to be 3, 0. Now I'm not going to do BC, because I'm going to leave that as part of the CF. So let's go around. CD is 3, and that is now going to be 6 and 1.5, so 7.5 across, 2 up. DE is 10. Now, we've got to go 6 and 3, so 9 across. That bit's the straightforward one. And then obviously we want 5 down here, but that's 2 is above the axes and 3 then will be below the axes, so -3. And then we got EF, so we're going across 6 and 1.5, so 7.5, same as this one was across, but then we're going from A and down 4 and then down another 4, so -8. So let's do this CF. So that's going to be across, so it's got a size of 10, it's going to be across 6, and it's also going to be down, let's see, -3, isn't it? So, we're going across here and -3 down, because that then gives me 5 down in total. Now I've got G to H, so that is 6, it's 3 across, 4 down, and then we've got AH, which is 4, and that's 0 across, 2 down. And because we've done quite a few there, just want to double check I've got the right amount, I haven't missed any. So we've got 1, 2, 3, and 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's going to be a total of 42 X bar and Y bar. Now that we have our centre of mass of our framework, we can go ahead and work out T1 and T2. Okay, so here we have it's 11/2 or 5.5 across, which will be, just shy of this line, and -2.6 down, that's 4 down, so just down by here somewhere. So just going to pop it in about there. So that's what we're looking at roughly for where our centre of mass will act. So right now it's obviously going to be acting straight down. Now we're going to work out this T2, so you need to think about, the horizontal and vertical components of this T2. So we've got T2 and T2. This will give me an angle of 30 as well here. So this is T2 cos 30 and T2 sine 30 on the top there. So resolve in vertically means that T1 plus T2 sine 30 is equal to W. And next then I want to take moment. So taking moment, and I'm going to take them about D so that I can take that diagonal one out of it. Okay, because obviously then it's got 0 distance, so it's not going to affect it. So I think that'll make my life a bit easier. So that means I've got T1, and that is 3, 9 away, so 9T1, and then we've got our W, which that's 5.5, but this total distance is 9, So 9 minus 5.5 is 3.5, isn't it? So there we have T1 equals 7 over 18W. Therefore, we've got 7 over 18 plus T2 sine 30. Well, sine 30 is a half, isn't it? So we get 7 over 18 plus, oh, sorry. I missed out that W there because that is very important, isn't it? So half T2 equals, so if I take away 7 over 18, that gives me 11 over 18 W, doesn't it? And then multiply by 2, so we get 22 over 18 W, or 11 over 9 W there. Hopefully that wasn't too difficult to follow. I think it was quite straightforward. But yeah, certainly taking moments about D just to get rid of that more awkward one, I think was the smarter decision to do here. So our centre of mass is still in the same position, which is roughly here. D is gonna snap, and then it's gonna hang essentially then from A. So what I want to do is I want to make sure that I draw a line through my centre and through A, because that's now the important line, isn't it? That's where it's going to hang from. So I've left with something like this, just so you can visualize it. Now we need to find the angle that AB makes with the vertical, so we're looking here, that's AB. Obviously we've got our G here, obviously I do actually have another G in there which I didn't see before. Let's just call this G1, which is our centre of gravity, centre of mass here. So here's my triangle, should be quite straightforward. Let's make it nice and clear. So we got, this is my theta, that's my value of A. This is my G1, which we're calling it. So this distance here is this distance. I'll pop it on the original diagram as well, so you can see that is what we're trying to find there. And this is my centre of mass. So what we know is that this horizontal distance here is still the same as before, which is 11 over 2. So this is 11 over 2, which is my A and in the direction of B. And then this is minus 55 over 21, isn't it? Which as a distance would just be 55 over 21. I don't need that kind of negative sign there, okay, because it's just a distance. So tan theta is opposite over adjacent, and that gives me 25.5 degrees to 3 significant figures. Hope you found the video useful. Any questions, just put it in the comments. If you haven't subscribed, hit that subscribe button, it doesn't take very long. And just also let me know in the comments if there's any other kinds of videos that you do want to see in the upcoming weeks.